Yes. Hello everyone. Welcome to the new session. So in this session we are going to discuss a new topic in chemistry, that is how to calculate number of lone pairs and how many lone pairs are available on a central atom of a molecule, only central atom of a molecule. How many lone pairs are available with the help of group number and number of sigmas as well as number of pi bonds present in a given molecule, right? So the concept is identification of lone pairs. This is how many lone pairs are present in a given molecule can be calculated. Identification of lone pairs. Right. So for this one common formula is there. If you want to calculate a number of lone pairs here, lone pairs is equal to, now write down group number minus number of sigma bonds around central atom, number of pi bonds around central atom divided by 2. That is a formula. So what is G indicates? G indicates it is a group number of central atom. Group number of central atom. What is the group number of central atom? Now we know LP is nothing but a number of lone pairs of a given molecule in which gets surrounded by central atom. So what is G? Group number sigma plus pi, nothing but number of sigma bonds and number of pi bonds around central atom. So we'll understand by taking one example. Okay, this is a formula to calculate number of lone pairs present around central atom. Okay, see, if I take methane, we know methane having tetravalency around carbon, carbon having 4 bonds, and we know very well all 4 hydrogens are belongs to sigma bonds. So what is the group number of carbon? 4. Every time try to select central atom of a molecule. Now how many sigma bonds are present? Sigma bonds are 4 because around carbon 4 hydrogens are available. Then number of lone pairs are 0. Divide by 2. So then what is your answer? So 4 minus 4 or not? 4 minus 4 how much? That is 0. Means methane carry no lone pair. Okay. Now one more example I will show, that is well known molecule, that is ammonia. You know ammonia? Nitrogen belongs to which group? 5th group element, right? Carbon, silicon and nitrogen, phosphorus. The 2 elements will be there in every starting group of a corresponding molecular structures. So that may helps to predict the number of lone pair. So carbon, silicon, germanium, tin, lead, 4th group element. Nitrogen, phosphorus, arsenic, antimony, bismuth, 5th group element. So every time try to select a central atom in that molecule. Central atom of nitrogen, ammonia is nitrogen. Nitrogen belongs to 5th group, right? That is 5. Then how many sigma bonds and pi bonds around nitrogen? Only 3 sigma bonds are there. Any lone pair? Any pi bond is present? No. So I can say divide by 2. 5 minus 3, 2 by 2. 2 by 2 means what? 0. Sorry, 1. 2 by 2. 5 minus 3 is how much? 2. 2 by 2. 2 by 2 is 1. Means on this nitrogen how many lone pairs are present? 1 lone pair. Suppose if I take water molecule H2O, how to calculate? So group number of oxygen is what? 6th group element it is. So 6 minus how many lone pairs are present? That can be calculated if you know sigma bonds. Every hydrogen is 1 sigma bond. Here 1 sigma bond and here 1 more sigma bond. Total 2 sigma bonds. There is no pi bond. It is further divided by 2. Now 6 minus 2, 4. 4 by 2 is how much? 4 by 2 is 2. Means you will get 2 lone pairs. Okay. And if you take hydrochloric acid, this is well known example, hydrochloric acid, HCl. Now just assume that chlorine is a central element. If chlorine is a central element, now chlorine belongs to which group element? 7th group element. Number of sigmas, how many? Only 1. There is no lone pair. Then see, here how much you will get? 3. 7 minus 1, 6. 6 by 2 is how much? 3. So around chlorine how many lone pairs are present? 3 lone pair. You can also write like this. Here 1 lone pair, 1 lone pair, 1 lone pair. Around oxygen how many lone pairs are present? 1 lone pair, 1 lone pair, and here 1 more lone pair, like that. So that is a way of calculating how many lone pairs are present. Now I will give one more example. Just listen. You know xenon trioxide. Can you guess? Xenon. Which is central atom in this molecule? Central atom in this molecule is xenon. Xenon belongs to which group element? Xenon belongs to 0 group element. Helium, neon, argon, krypton, 0. So, xenon belongs to 0 group element, also called 8th group element. Write down 8. How many sigma bonds are present? Every oxygen carry 1 sigma and 1 pi. Every oxygen. So, 3 sigma and how many pi? 3 pi. Then divide by 2. So, 8 minus 6 by 2. 2 by 2, 2 by 2 means 1. Means xenon carry how many lone pair? 1 lone pair. Okay. Now, can I give one more example? Xenon tetroxide. Now, can I write like this? 8 minus 4 plus 4 by 2. 8 minus 8, 0. 0 by 2 is how much? That is 0. Means how many lone pairs are present on xenon tetroxide? 0 lone pair. Suppose, regularly if you observe clearly, I am taking a neutral molecule, sulfur trioxide. Neutral molecule I am taking. Logically you need to identify. Sulfur trioxide. Sulfur belongs to which group? Sulfur. 6th group element. So try to practice periodic table. Elements, at least what is element abbreviation, what is that element, and what is group number. Okay, because element and group number will place an important role in inorganic chemistry as well as even physical as well as organic. Element and their corresponding group number. In last class I given that one, just go through it. Okay, carbon, silicon, germanium, tin lead, 4th group. Boron, aluminium, gallium, indium, thallium. Okay, do you have that periodic table? So you ask me after the class, I will provide you. Okay, sulfur belongs to which group? 6th group element. Write down this. If you don't know this one, you will face some more problems. So that's why try to practice corresponding group number. Okay, group number is most important. Then how many sigma bonds are present? 3 sigma bonds, 3 pi bonds, divide by 2. 6 minus 6, how much? 0. No lone pair. Sulfur trioxide carry no lone pair. Is it clear? You can guess very easily. You can say xenon trioxide, 1 lone pair. Xenon tetroxide, no lone pair. Sulfur trioxide, no lone pair. Can you guess sulfur dioxide? Sulfur dioxide, how many lone pairs are present? Sulfur belongs to 6th group, and here 2 sigmas, 2 pi, divide by 2. 6 minus 4 by 2, 2 by 2, that is 1. Means sulfur carry how many? 1 lone pair. Remember, we are calculating number of lone pairs only on one atom. Otherwise, you can say central atom of a molecule. So this is a formula not applicable for total number of lone pairs. See, on central atom, I am saying that only 1 lone pair. But see, every oxygen carry 2 lone pair. But how many lone pairs are there? Total number of lone pairs in this molecule? Total number of lone pairs of this molecule is 5. Every oxygen 2 oxygens are there? 4. 4 plus 1, total 5. But this number suggests number of lone pairs present only on central atom. In this central atom, sulfur, number of lone pairs are 1. Right? Take. Clear? Now see this. One more I will give. Just try this. I am giving POCl3. First you identify which is the central atom in this molecule. Which is central atom? Phosphorus. Phosphorus belongs to which group element? Like that you need to confirm. Phosphorus belongs to 5th group element. Nitrogen, phosphorus, arsenic, antimony, bismuth. So if phosphorus is 5th group element, can I write 5? 5 minus. How many sigma bonds are present? Oxygen, 1 sigma. Chlorine, 1 sigma. So 3 chlorine, 3 sigma, 1. And total will be 4 sigma. And every oxygen, 1 pi. So I can say like this. So this is divided by 2. then how much you will get? 5 minus 5. 5 minus 5, how much? 0. Means POCl3 carry no lone pair. Okay. Next, I am using SOCl2, thionyl chloride. SOCl2 is called thionyl chloride. Then sulfur belongs to which group? Sulfur is a central atom. Sulfur belongs to 6th group. And here how many sigma bonds are present? Oxygen 1, chlorine 2. Total 3. And how many pi bonds are present? 1 by 2. So 6 minus 4 by 2. 2 by 2, answer is 1. Means sulfur carry how many lone pair? 1 lone pair. Here phosphorus carry no lone pair. Okay. So you can also go through NOCl. NOCl. What is NOCl? Nitrosyl chloride. Nitrogen is a central atom in this molecule. Nitrogen belongs to 5th group. Every oxygen 1 sigma and 1 pi. Here 1 sigma, here 1 sigma. Total 2 and 1 pi bond is present divided by 2. So can I write like this? 5 minus 3 by 2. 2 by 2, is it 1 or not? That is 1. How many lone pairs are present? 1 lone pair. Is it clear? Next. You know borane? What is the formula of borane? BS3. Borane. Boron belongs to which group element? Third group element. It is third group. Boron. 5th group is nitrogen. So boron belongs to third group element, right? 3. Then how many sigmas? 3 sigmas, no lone pair, divide by 2. Now how many lone pairs you will get? 0. You know phosphane? What is phosphane? PH3. Phosphorus hydrates. Okay. Now phosphorus belongs to which group? 5th group element. Now 3 sigma bonds are present, no pi bond, divide by 2. So here 2 by 2, that is 1. So phosphorus carry how many? 1 lone pair. So this information clearly suggests that whether molecule having lone pair or not. Okay. Now I would like to take one cation. Just go through it. So what is the meaning of a cation? Cation means positive charge species. How to calculate number of lone pairs in a given cationic molecule? Carbon carry which group element? Now I would like to calculate how many lone pairs are present on this carbon. So first you need to know group number. Group number is what? Carbon. Carbon group number is 4. Okay. So in that 4 I want to remove 1 electron. Plus means need to remove 1 electron. Now here I can say 4 minus 1. 4 minus 1. This is group number minus 1. This charge will be used here. Suppose if plus 2 is there, remove 2 electrons. Plus 3 is there, remove 2 electrons from group number. 4 minus 3 how much? 4 minus 1. 3. Then how many sigma bonds are present? 3 sigma bonds. No pi bond. Divide by 2. So 3 minus 3 0. Now no lone pair. Why I written 3 even though group number is 4? Why I written 3 even though group number is 4? Because from group number the charge will be removed. Suppose if group number is 4, if you want to remove 2 electron, 4 minus 2, write down 2 here. Okay. Now, can you work out this example? See, I am writing ammonium. Ammonium. Nitrogen belongs to which group? 5th group element. Can I remove 1 electron or 2 electron? 1 electron. Then 4. 4 minus, how many sigma bonds are there? 4 sigma bonds. Any pi bond? No. 4 minus 4. Now answer is 0. Okay. Now I am using H2O plus, H3O plus. What is H3O plus? H3O plus is nothing but protonated water. Water is also called acidified water. It is also called protonated water. Now acidic solution. Oxygen belongs to which group? 6th group element. Remove 1 electron, it becomes 5 minus. Now how many sigma bonds are present? 3 sigma bonds, no lone pair, divide by 2. 5 minus 3. 2 by 2, 2 by 2 means 1. So means on this oxygen how many lone pairs are present? 1 lone pair is present. Okay. You know one more example I will give. See, this is ICl. Just you go through it. ICl, ICl3, ICl5, now IF7. Just can you give the answer? How many lone pairs are present here? Neutral molecule given. How many lone pairs present on ICl? Iodine is a central atom. How many lone pair? Iodine belongs to which group? 7th group element. Iodine belongs to 7th group. Means 7. Group number 7. 7 minus 7 minus, how many sigma bonds are present? Only 1. There is no lone pair. 7 by 2. So how much you will get? 7 minus 1 by 2, 6 by 2. Then what is your answer? Answer is 3. 3 lone pairs. Now in this one, can you calculate this one? 7 minus 3, 4 by 2. 4 by 2 means how many? That is 2. Like that, directly we can calculate. Answer is 2. Here, 7 minus 5. This is 7. 5 are monovalent. Sigma bonds they are forming. 7 minus 5, 2. 2 by 2, 1. And here, 7 minus 7, 0. No lone pair. Like that. See, by watching, we can calculate directly or not. Group number minus sigma. We know halogens never form pi bond. And here, every chlorine forms a single bond with iodine. And here also 3 chlorine forms single bond with iodine. So they are called interhalogens. These all are called interhalogens. What it means? What are interhalogens? Interhalogens are generally classified into 2 different types. AX type, AX3, then AX5, and here AX7. They are called interhalogens. So A is nothing but less electronegative halogen, X is nothing but high electronegative halogen. So they are this type. So they are having a monovalency, trivalency, pentavalency, and heptavalency. Like that. Clear? Now, so go through it. Now what I am saying is, I am giving one cation, just try to identify in this one. I am taking ICl plus. Can you calculate how many lone pairs are present? So you write better. ICl plus 2. Monovalence already you calculated, plus 1 you calculated. Go through additional charge. ICl plus 2. So iodine belongs to which group? 7 minus 2, 5. 5 minus 1. 5 minus 1 by 2. So means 4 by 2. 4 by 2 means 2. Okay. Like this they will increase the charge. In your exam they will give like this. ICl plus 4. ICl plus 4 like that. So 7 minus 4. 7 minus 4 is how much? 3. 3 minus 1 by 2. Then 2 by 2. 1 lone pair. Now, can I increase the charge? ICl plus 5. Sorry, plus 6 you take better. So that all charges are possible to create. How much? Here 7 minus 6. 7 minus 6 by 2. Plus 1 sigma bond. 7 minus 6. Then 1 sigma bond. So 7 minus 7 by 2. So means what is your answer? 0. No lone pair present over here. Now, if I take ICl3. ICl3 I am taking plus 2. Can you calculate? 7 minus 2, 5. 5 minus 3, 2. 2 by 2, how much? So you can write 2 by 2, answer is 1. Okay. So you can also calculate for ICl 5 plus 2. Can you calculate? How many? That is 0. So 7 minus 2, 5. 5 minus 5 by 2, answer is 0. Like that. So every molecule, by knowing the bonding interactions, and if you know minimum knowledge on structure clearly, then definitely you can calculate number of lone pairs. Okay. Now see this. I am giving one anion. Try to predict the answer. This is CH3 minus carbanion. Up to now we discussed only cation. Now it is anion. Carbon. See, when positive charge is given, we are start removing electron. When negative charge is given, keep on adding electron. So if you add electron, carbon is how much? Fourth group. 4 plus 1. When negative charge is there, add 1 electron. When positive charge is present, remove 1 electron. So 4 additional 1. How much? 5. 5 minus number of sigmas. So how many sigmas are present? 3 sigmas or not? So 5 minus 3 by 2. How much you will get? That is 1. So why I written 5 even though group number is 4? Because carbon bearing negative charge means it is a carbanion. Carbon, if they loses 1 electron, means it is a carbocation whose valence is 3. Is it clear? Now see this. I am going to give one more. This is NH2 minus. What is NH2 minus? Amide. NH2 minus is amide. Can you say the nitrogen group number? Nitrogen. 5th group element or not? It is 5th group. And minus charge is there. 5 plus 1? 6. So 6 minus. How many sigma bonds are present? Only 2 by 2. Now how much you will get? 6 minus 2. 4 by 2. How many lone pair? 2 lone pair. Amide carry how many lone pair? 2 lone pair. Is it clear? Very easy. And if you take one more, hydroxide ion, they will ask like that in your exam. Very short points and they are most important for your examination. How many lone pairs are present in hydroxide ion? If they ask like that, what is your answer? Oxygen belongs to 6. 6 plus 1, 7. 7 minus 1 by 2. 6 by 2, and here this carry 3 lone pair. Suppose if I give O minus 2, monoxide, this is called monoxide. O minus 2 is called monoxide. Now here how many lone pairs are present? Every oxygen belongs to 6. 6 plus 2 how much? 8. 8 minus 0. There is no sigma bonds, there is no pi bond. Divide by 2. Then how much will be the answer? Answer is 4. How many lone pairs present in O minus 2? 4 lone pair. Is it clear? 4 lone pairs are present in given molecule. Now see, suppose if I take Cl minus, chloride, chloro, even in inorganic chemistry, coordination chemistry it will come. Chloro, bromo, iodo, like that. Some ligands are going to come. Chloro, this is called chloro. Chloro carry how many lone pair? It is 7 plus 1, 8. 8 minus 0 by 2, same formula. Now you will get 0. Sorry, 4 lone pair. No sigma bond, 0 nothing out, no sigma bond. Now total number of lone pairs are 4. Now the most important one, it will come. See, if I write SO4 minus 2, what is SO4 minus 2? Sulfato. Sulfato. Okay, just imagine every oxygen can form, wherever oxygen is appeared, just imagine it can form one sigma bond and one pi bond. Now sulfur belongs to 8th group element or 7th group element, 6th group element. 6 plus 2 how much? 8. 8 minus how many sigma? 4 sigma, 4 pi divided by 2. Then what is your answer? 8 minus 4 by 2. So now answer is 0. Sulfato carry no lone pair. It is coming from which acid? Sulfuric acid. Right or not? It is coming from sulfuric acid. That's why no lone pair of electron. Now SO3 minus 2 if I give. SO3 minus 2. Sulfuric acid. So here sulfur belongs to 6 plus 2, 8. 8 minus 3 lone pair, 3 pi bond divided by 2. Now here 2 by 2 you will get 1. 1 lone pair will be there. Okay? Let's take 2. Clear? Now just go through it, calculate and give the answer. NO3 minus 1. How many lone pairs are present in this molecule? NO2 minus 1, NO2 plus. Nitronium. For nitration reaction, this will be a common use. Now select the suitable formula and give the answer. I3 plus, I3 minus. Nitrogen belongs to which group? 5. 5 plus 1, 6 minus. Every oxygen carry 1 sigma and 1 pi. So can I say directly 3 plus 3? 3 plus 3 divided by 2. How many lone pair? 0. Simple. Now here in this one, nitrogen 5 plus 1, 6 minus. How many sigmas and how many pi's are present? 2 sigma, 2 pi divided by 2. Now how much you'll get? How much you'll get? NO2 minus 1. 1 lone pair or not? 6 minus 4, 1 lone pair. 4 by 2. 2 by 2 will get. So 6 minus 4, 2. 2 by 2, 1. Now NO2 plus nitrogen 5 minus 1, 4. 4 minus 2 sigma, 2 pi divided by 2. Then answer is 0. No lone pair. Now I3 plus. I3 plus. One central 1 iodine is there surrounded by 2 iodine. Remember total how many iodines? 3. 3 iodines are available, but in which central iodine gets surrounded by 2 other iodines. Means 1 iodine is taken as a reference. 1 iodine taken as a reference. 1 iodine, if you remove 1 electron, then what is your number? 6, right? Iodine belongs to which group element? 7th group element. So remove 1 electron, you will get 6. Now how many iodines are surrounded? 2 iodines are surrounded. So they will form either sigma bond or pi bond. Only sigma. So we can write 2 sigma, there is no pi. 2 sigma, no pi divided by 2. Then how much you will get? Will you get 2 or 3? 6 minus 2, 4 by 2, 2. How many lone pairs are present? 2 lone pairs are present. Okay, now in this one. I3 minus 1. I3 minus means iodine carry 7 plus 1, 8. 8 minus. See, generally the common mistake done by students is, here there is a 3 is present, so they will think that 3 iodines are present and they will write 3 sigmas. That is wrong or not? See, out of 3, which is central atom? Iodine. If iodine is central atom, remaining 2 are surrounding atoms. Then for this central atom, how many sigma bonds are present? Only 2. So I can say 2 by 2. Then how much? 6 by 2, how many sigmas? Lone pair, 3 lone pair. How many sigmas are present around I3 minus 1? 2. So this molecule they given and they ask a question like this. See. So they given like this. The number of lone pairs. The number of lone pairs present in I3 minus 1 is. How many lone pairs are present in I3 minus 1? So option A, they given 3. Option B, they given 6. Option C, they given 9. Option D, they given 4. So this is one of the question which is given in exam. What is correct answer? The number of lone pairs present in I3 minus 1. Answer is, how many lone pairs are present? 3 or 6 or 9 or 4? 3 lone pair. That is not right. Answer is 9. He was not asking central atom. He was asking in this molecule how many lone pairs are present. But what is the formula? This formula belongs to only for central atom. But here how many iodines are present? See, this is iodine, and here one iodine, other iodine. Here one lone pair, here one lone pair, and here one more lone pair. One lone pair, one lone pair, and here one more lone pair. And here how many lone pairs are present around this one? 3 lone pair. And here also 3 lone pair. This is actual structure. It is gets surrounded by which charge? Negative charge, -1 like that. I3 -1. But what we are calculating actually, the formula which I given, that is only for central iodine. But actually, if you consider total molecule, in this molecule, if you consider surrounding atoms even, 1, 2, 3, 4, 5, 6, 7, 8, 9. So answer is 9. So be careful, way of asking is different. So if they ask how many number of lone pairs present on central atom, means say this formula can be applicable. Suppose if they ask how many lone pairs present in a given molecule, means you need to count total molecules. First you count central atom. By using this formula, you will get central atom lone pair. Then surrounding atom lone pair we need to calculate. Okay. So answer is 9 but not 3. But they will give logically first option. See, generally what you will do, you people, by applying this one, you will say 3 lone pair. First option is ready. You won't see other options. You won't think about. That's why try to listen question completely. The number of lone pairs present in I3 minus. He was not asking central atom. He was asking in that molecule how many lone pairs are present. That is the question. Is it clear? Yes. So that is about way of calculating number of lone pairs in a given atom present in a molecule. That too central atom. And one more, we can also calculate total number of lone pairs present in a given molecule with the help of this formula. This formula will give information about how many lone pairs only on central atom. By knowing the valencies around central atom, one can easily identify total number of lone pairs in a given molecule. Clear? So that is about concept of identifying lone pairs. In your next session, we will discuss with a new topic. Okay? Thank you.